Hello everyone, I'm Marjan from Yonsei University Photonic Device Physics Lab under supervision of Professor. In this presentation, I'm going to briefly talk about my research plan and at the end, I will briefly talk about future job results position. Recently, the biomaterial has attracted great attention in photonics, optics, and the other research area because of its properties. In my research, I'm focusing on the RNA, DNA, and nucleobases material. For measuring the optical characteristics, we need to make optical components such as thin films. For making the thin film, we need to select the appropriate deposition methods. Maybe we can use spin coating, drop casting, OMBD. Depends on our material, we can select it which one is suitable, which one is not. For spin coating and drop casting, we need to make a solution, but OMBD is just use a powder type. Then, by applying the different equipments such as spectrometers, ellipsometer, we can measure the linear characteristics. According to these properties of device, we need to deposit material on quartz or silicon substrate. You can see that absorption results and comparing the RNA and DNA both shows the absorption peaks around 260 nanometers and after that they almost transparent. Ellipsometers help us to measure the refractive index. Actually measuring the refractive index depends on many parameters: deposition methods, concentration of a solution or your material, thicknesses, environmental temperature, all of them affects your results. But the only things we can say that if we add the thickness or concentrations, we will get the higher refractive index. I'm talking about the RNA results I'm recently measured in our lab. Next one, which is very useful for sensor applications, is thermoptic coefficients. It's a study of change refractive index corresponding to temperature. The equipment we need to use in these measurements is ellipsometer and the hot plate like that to control and optimize the temperature in each step. The range of temperature really depends on the material you are applying. It's clear that as the thin films, when exposure to higher temperature, it will reduce the thicknesses and affects the refractive index results. Both the figures confirm that which thicknesses results and which thicknesses decreases and refractive indexes decreases when we increase the temperature. The most important things we need to focus on before applying the ultra-fast pulse laser is nonlinear characteristics to know whether our sample or material is suitable to be applied for generating pulse laser or not. For measuring the nonlinear refractive index and absorptions, we use the Z-scan setup, closed aperture and open aperture. These two setups give us the data like that. I show you the DNA results which was published recently with our group research. And we are expected that the RNA shows the similar behavior like DNA. The other one is nonlinear transmissions. In these measurements, we need to use the femtosecond lasers. Then we inserted the saturable absorber means our samples. Saturable absorption is the optical phenomena which is related to nonlinear optical characteristics of material, which depends on the light intensity. And by polarization control, we can control the intensity, and the results is like that. It is for DNA, and by simply calculating, we can get the modulation depth. Saturable absorber, which is needed for our ultra-fast pulse laser setup, can be used in different types: end phase, taper fibers, or side polish fibers. Each type depends on the material and its characteristics. We have to try different methods to find out whether it's proper for our measurements to make the pulse or not. And the erbium doped fibers usually used for C band and L bands. It's a gain medium to amplify the power in this cavity, this laser cavity. We are expected that to get the optical spectrum results like these two for Q switching and mode locking. I just put the sample figures for DNA and RNA to show you the difference between Q switching and mode locking. In Q switching, we have the central peaks, which is surrounded by the short peaks. Okay, for graduate students, maybe it can be useful, these parts maybe can be useful, especially for photonic researcher to prepare ourselves in advance for a well-suited job for the future. I just focus on the USA job positions and looking for this position in Indeed websites. Some of them It's related to photonics engineer, fiber optics engineer, biophotonics, and so on, maybe optical science. Some of them needs to improve our programming. Some of them needs to improve our experimental skills, and all of them, especially in our research area, at least needs master degree or PhD in relevant research field, like biomedical engineering, physics, electrical engineering, optics, and photonics. Hope this position can be useful for graduate students or listening to my presentation. That's it, and thank you for listening to my presentation.